thought I would share just some sort of observations, thoughts about a recent upgrade to our ingress that we made. There's probably not a whole lot of like revolutionary stuff in here, but a little bit of stuff that I wish I had known when going in, and just some experience, and you know, it might be an opportunity for everybody to just sort of get a sense of what they're doing for their ingress on clusters, and some of the trade-offs certainly that we've made. I think that might be one of the key pieces. So anyway, I'm Brad. I'm the recently named CTO at Fruition, which is a digital agency in Denver. We do marketing as well as technical implementation work. So we're sort of unique in that sense that a lot of agencies like just do technical design work. We do some marketing as well. So sort of a full-rounded agency here in Denver. You can find me on all the places on Drupal.org and yeah, at fruition.net. So anyway, a quick agenda, just sort of a quick review of Kubernetes ingress. Why are we doing this? Our history about why we ended up using Traffic 1.x. What predicated our decision to move to Cert Manager and Traffic 2.x, and some of the trade-offs that we had to make just due to technical limitations and business decisions. And then just a few tips, and I've got like a few little code snippets too about migrating ingress sort of while you're going down the tracks, because clients don't like it when you take their workloads down for reasons that don't include anything that really they see might directly benefit them. So part of my involvement at Fruition, I was a contractor for about 1.5 years before moving into a full-time role here. And largely I was brought in to help architect and implement what we call Fruition Cloud, which is really Kubernetes with some sort of opinionated control plane, and you know, quality of service, SLA, that kind of thing for clients. Fruition Cloud is an internal product in the sense that we do not sell it directly as a commodity product, unlike, for instance, what like DDEV is doing with DDEV Live or Platform SH or Amaze.io. You know, it's possible that we might do that down the road, but really, you know, this is a value add play for us to provide our customers a platform that we believe meets their needs, but primarily the consumers of this are internal. So part of how we ended up choosing the ingress that we chose, right? And an ingress, you know, for the more uninitiated is, you know, a mapping of resources inside of your cluster to the outside world, right? The outside world might be a internal load balancer inside of a data center, right? It might not be public to the internet, or in our case, it is like a network load balancer from Google Cloud that has Kubernetes nodes inside of its targets, and then we further have to map that traffic to workloads inside of Kubernetes. So when we were architecting Fruition Cloud, I was, and still am, and to a large extent, sort of a one-man band architect and engineer on this. So our goals with it, we wanted to, you know, reduce toil, improve our uptime. We were coming from a bare metal sort of cPanel, old school hosting environment. We wanted to improve security, right? Give us the opportunity to automatically issue Let's Encrypt certificates, and also give us just a more unified plane to do security, right? In cPanel land and VM land, you know, every VM, every install needs, you know, its own sort of high-touch maintenance, and we wanted a more unified control plane that we could enforce policy on. And developer experience is a huge piece of it too. We wanted to be able to allow developers and sort of internal site owners to be able to spin up sites with, you know, TLS and sensible defaults without needing to ask a guru like ops person for permission. And we wanted to lower our cost of ownership. And our ingress requirements, we ended up using traffic, which if you're not particularly familiar with traffic, it's one of the many ingress controllers out there, right? And an ingress controller being the workload that runs inside of your cluster that translates the declarative ingress definitions in your Kubernetes ingress objects to whatever maps that traffic, right? So in this case, it would be listening for traffic and then routing it to the services that are defined in the ingress. That's a rather reductionist explanation, but there's many out there. Google, for instance, provides a default ingress controller, but you get like a new external IP load balancer per object, which gets very cost prohibitive very quickly, and it doesn't allow us to, for instance, like publish a single IP. And also we wanted to consolidate our control plane. So we really wanted people to be able to use, we use Rancher, for instance, as sort of a reverse proxy / UI in front of Kubernetes. We can't go from 0 to 100 on going straight command line only Kubernetes. We needed something that would allow us to let developers internally who didn't have cloud native experience be able to manage their ingress. And so paired with us using Rancher for that sort of control plane, we wanted to be able to increase that self-service, right? Not require gurus. And most specifically, we did not want to require anyone to sort of do extra steps to set up certificates. And that was really the key sales point for traffic. We ended up using traffic 1.x for a controller. Yes, cert manager, and before that, Lego was the predecessor to cert manager. Can't remember exactly when the first release of it was, but the pros for us was that traffic handled a lot of the messiness of having to hook up, right? There was no intermediary between creating an ingress object. If you turned traffic on with the Acme implementation in there, you got a Acme certificate, right? You got a Let's Encrypt certificate. And that was the key for us, is that we didn't want to require developers to have to mess with additional YAML in their ingress. The cons ended up actually being a rather long list. The documentation for traffic, quite frankly, sucks. It's getting better for 2.x. I ended up contributing some, what I believe, kind of key documentation edits because some of the WTF kind of situations, stuff not exactly working the way you thought it would. And those, to Containus is the company that sponsors it, to their credit, they've been cooperative with that. But unfortunately, in the case of a few situations, the documentation led us to situations that either caused us some actual grief with clients relating to like client certificate validation not exactly working the way that the traffic advertised. But specifically, the clustered Acme agent inside of Traffic 1.x is buggy. Works 98% of the time, but basically you have to run etcd or console in cluster, right? You can't use the same etcd that runs your Kubernetes cluster, and only after deployment and only after 90 days or so, when your certificates are up for renewal from Let's Encrypt, do we find that we would get these difficult to debug race conditions. There were leader election issues with the clustering there, and because it was basically either on or off, right? You put a host into a route definition or a route rule in a ingress object, you get a certificate, and we would get these weird situations where like certificates would renew and get added to and they would start serving on other domains, right? So you'd have certificate mismatch issues. Really difficult to debug because all of a sudden now you're having to like connect to your etcd store and like manually dump and then like patch objects, really difficult. So traffic 2.x is a big departure. It's much more feature rich. You can actually use it to like do things like TCP proxying on the same install, which is really great. It does have support for sort of what they're calling like legacy, but really what is the native Kubernetes ingress object. And they also have introduced, as a lot of people have, moving forward here, their own custom resource definition that allows you to really, more declaratively target like traffic's configuration model. Because we were migrating from default ingress objects and we use Rancher as a control plane there, that's the route we're going, right? I don't have a developer-friendly UI for their CRDs. Much more robust dynamic configuration feature set. You can like dynamically configure middlewares. So for instance, we use middleware to like define certain sites to have no index headers. For instance, if it's internal tooling or it's a site that's not ready to launch yet. And it's much more stable. The documentation still sucks, but it's better and it's getting better. They've done a lot of work there. But however, clustered Acme is gone. And so that's why we had to switch. Also, their release cadence, it's worth noting, is rather slow. They do not release sort of like nightly builds. So we had to actually build our own image from a pinned commit to get some of the features that were committed into like master but haven't been released yet. So in planning our upgrade, planning actually was really important here. We wanted to, while we were switching, take advantage of the fact that many of our clients are behind Cloudflare. And I'm sort of ambivalent about Cloudflare. I think some of the magic that they promise is a little funky and can get in the way. However, it's, for the free version, a lot of our clients get a lot of value out of it. And there, we can actually remove the idea of even having to be issued a certificate because we can outsource that to Cloudflare and we can get an origin pull certificate, pull that in, and just put it into a Kubernetes certificate object that will be picked up by traffic right off the bat. So one thing that we were able to do, I'll show you some tooling here in a minute, is just run a shell script to identify which of these sites are actually behind Cloudflare, do an audit, plan pulling those origin pull certificates in, and it makes our maintenance a lot easier because we don't even have to worry about getting certs. Shell scripting, if you are doing Kubernetes, I mean, this is sort of goes without saying, I think, for people who are neck deep in it, but shell scripting is a huge skill if you're going to be sort of, leveling up in your engineering skills here, because as you'll see in the next few slides, like a combination of kubectl, JQ, awk, some of these very old school tools are super important in sort of doing these one-off upgrade tasks that you can commit to a repo and get code reviewed and all the rest, but did a lot of shell scripting in moving forward. Have a rollback plan, that sort of goes without saying, and run it first on your staging environment. The key here, this is sort of the slide that sums up a lot of what we did. You can have more than one ingress controller running concurrently in your cluster. And this, might sound a little pedantic, but it's true, and allows you to, this could be part of your rollback plan, right? Our rollback plan essentially was keep the service, right, that has an external load balancer attached to it, the service that points traffic to your ingress controller, run your new ingress controller inside of the pod on different ports than the old one, and then all you have to do to roll back or roll forward into your new controller is change those ports, right? Just because you're handling, unencrypted plain text traffic on part of your ingress doesn't mean it all has to be port 80 after you terminate it, right? So you can change port 80 to port 8081. That's your current controller. 8088 or whatever you want to do is your new one, and you can sort of A/B your traffic with a quick edit of a service. So get creative with your port mapping. The other thing that we do, and I've got some configuration snippets here that I'll show you toward the end, is having a split horizon, right? So we actually, turn most of the unencrypted traffic around with a 301 redirect to the HTTPS version because we're full-time encrypted. However, we let some unencrypted traffic like Let's Encrypt or Acme challenges come through. So stand up all of the pieces that you can before your conversion, right? Stand up Cert Manager, point your challenge route to your new controller that has Cert Manager running with it, right? You can do that before sending all of your production traffic to the new controller. So again, I don't want to cross your eyes, but just some examples of some of the code that we had worked up to do this conversion. For instance, this is a script that we ran to help identify, right? I'm using kubectl to get all of the ingress objects that don't contain what we basically have as a wildcard temporary URL, right? So live sites. And spit out those rules. I pull in the known IPs for Cloudflare, and then use tools like, for instance, grepcider, right? So I can just run a quick comparison against the known Cloudflare IPs, right? So this kind of tooling allowing us to, just an example of how, Quickie shell scripts are a tool in your toolbox that you shouldn't overlook. Here's another one, for instance, that just is an example of patching, right? So again, grabbing a certain class of ingress objects, you can get really creative with JQ in transforming the JSON output. So many times when we're doing edits on Kubernetes objects, we prefer YAML because it's sort of more easily human editable, but JSON is really easily pipeable into JQ. And then, this is a great opportunity. I learned a lot about sort of the, JSON the JSON patching functionality in kubectl patch. So I learned a lot about, sort of more Kubernetes internals doing this. And part of it is because I really spent time working up these shell scripts. And then finally here, just an example of, this, so talking about that split horizon, right? You can even inside of the pod that you're sending all of that external traffic to, inside of the pod, I actually have Nginx listening first as a reverse proxy in front of traffic, our ingress controller. I have it, and there's a few rules here, right? So if it's an Acme challenge, we let it through because those come in plain text. I also have a quick known path that I can use to, for instance, validate the traffic is even coming to us, right? So if I want to make sure that a client, that something is propagated, I can look for that path and it replies with 418, I'm a teapot. And then otherwise, we just turn around and redirect traffic. So again, that's a very, sort of quick, that's a quick summary of what we did to work on our ingress conversion. Hopefully there was something there that identifies with you. Hopefully that was helpful to somebody there as a summary. And if you have any questions about what we did or why we did or why we made the trade-offs that we did, I'm happy to take them. Or silence gives consent.
Brett, hey.
Yeah.
Nick here. I work with Kevin and Ellie and Jason at eDev Live. Greg. And I had a question about when you upgraded from traffic 1 to traffic 2 and implemented Cert Manager. How have you handled the Cert Manager upgrades throughout that process?
So that's a good question. So what I chose to do was, I did consider basically like pulling, because The cert, traffic one stored its generated certs in what essentially was just a big giant JSON file that got stuck into an object in the key value store. I did consider sort of pulling some of those out, but it was going to be way too much work. And so what I did was I had some of those kind of scripts that went through, and all I did was update, because the ingress, Cert Manager chooses to generate certificates based on annotations on the ingress. You can set up a shim where you just have like a cluster-wide account set up. And so I looked at the rate limits, and I knew that, and I validated that all of the challenges would work. And so I just opted to run a shell script that went through and pulled out the configured rules, the hosts, and added them into the TLS stanza in the ingress record. So we didn't actually migrate the certificates. I validated that we weren't going to be up against any rate limiting, and I just had them reissued. And also we had a subset of sites that we just knew that we were going to set up origin pool certificates from Cloudflare, so that reduced the number of sites that we actually had to reissue, if that makes sense.
Yeah. I mean, it's very similar to an issue that, we faced, and, Cert Manager upgrades, especially V1, V2, and hopefully 1.0 soon, kind of have to stick it out for the time being until it's stable.
Yeah, and the upgrade, the Cert Manager documentation is really good, but I did notice that the upgrade documentation is sort of like, yeah, just like turn on Cert Manager and point it at your ingresses and it'll like upgrade. And it's not real clear as to exactly how that works. And I tried to read through the code, and it was sort of opaque. So I just, it was easy enough to just do a reissue.
Yeah. Well, thanks for sharing.
Yeah, thank you.
Anybody else have questions?
Did you consider using or trying to use Customize to try to do some of the manipulation? Some of the things available in there, like transformers, I've found it. I've been using a technique recently where I will download the resources that I'm using and then apply like a customize with a K transformer on those objects. And you can pipe that then into kube control or do a -K. The reason being, I heard you talking about the challenges around manipulating manifests. I in particular, the most notorious is finding the container name or manipulating a value in a container within a pod spec and a deployment. Thanks for pointing out the awk tools though, and the SED and grep especially. They're lifesavers with kube control, man.
Yeah, I didn't. I mean, I'm going to star customize and sort of see, it sounds like it's sort of same. It might just be a different tool chain to sort of get to the same place. What was more so than sort of like choosing how to target the right thing was rolling up different values. Like I got much better at JQ, sort of saying, okay, like pull this sub value, right? Pull the host out of all of the different rules, right? And then give me an array of all of those that I have to stick into the TLS stanza. So I'm sure Customize probably would have been a good option there, but it was also, I felt safe. I felt like I had been able to do enough validation, and it was a safe enough transform that it wasn't a high risk operation. But I appreciate the pointer to it. I just hadn't even seen it before you mentioned it just now.
Yeah, it's. I heard the suffering there, and I was just like, check this out.
Yeah, and it actually wasn't so bad in that, I saw it as an opportunity to level up my skill there. Like I knew that, for sort of a quickie one-off, like this was a decent tool to do and it wasn't overkill. I guess it's just, for me, like, a lot of us in this room are like PHP developers sort of by history, and it's like, oh yeah, like I could just write a script or whatever, and it's like, actually no, like this is what shell scripting is for. This is why people write shell scripts.
It is. It's the first step to automation is all those manual command line arguments. Getting moved into a script. I may have missed it on your list. Did you, in your evaluation of Ingress controllers, did you consider a service mesh, which can provide?
Yeah. So, the piece that really is important for us in this transition is maintainability and reducing complexity. I would love to, Containers has a product called Mesh or whatever, the A and the E are merged. Istio is, I guess, supported sort of out of the box, and I know like Rancher, I think, has some sort of service mesh thingy, Majig routing, something that maybe they're working on. The problem for us is that, when the audience for this platform is mostly internal users, and most of my internal users are busy like writing code and doing other tasks that don't require them to be cloud engineers. And so, especially since we're using Rancher as sort of I like calling it a bridge, right? I'm a bit limited by what I can control with that control plane, right? I think Rancher's got an interesting future, and like eventually maybe we'll even roll some of our own control plane, but like for the reason that like we're continuing to use first class ingress objects is because there's a UI for it inside of Rancher. I can't move to the CRDs because sure, if you know how to use kubectl, you could edit them, but there's no other path to maintaining them.
Yeah, the reason I bring up the service mesh is that, especially I'll point to Istio, is that the project is more mature. There are more features available to you. It's Envoy that's backing that's doing the load balancing per se. That's to your point. That's one of those things I do look at when I'm considering a particular product or an option. There is which one has the best documentation.
Yeah, and traffic, we got sort of burned by that, but the other piece of it is that, we could over-engineer this, right? That's always a risk. And so I'm trying to not over-engineer it and keep it as vanilla as possible, just given my internal user base. But it's all well taken. And there's no right or wrong answer about what your ingress controller is, because there's like 50 of them. So
last we checked, probably.
Cool. So we do have another presentation here from Florian. So I don't want to take too long on our conversation, although it sounds like you all have lots to talk about. So definitely continue in the channel.
Thanks for letting me present. I appreciate it.
Yeah, it's great seeing you. It's great seeing you again.
Thank you very much, Brad. That was enlightening. Florian, do you want to hit it?
Yeah. So let me just share my screen. So yeah, can you see this?
Yes. The whys and hows of Helm 3.
Yes, exactly. So I work with Winter. I'm also CTO there. So actually, a situation that has a lot of parallels, different country, different time zone as well. But also done plenty of bash scripting in the past, many months, and also using traffic. But the thing I want to talk about today is Helm. We actually had some interesting discussion, already way back at DrupalCon about using Helm versus not using Helm. But we're actually very happy with it. I gave this presentation internally. I told a bit more about Helm, what it is and what it's for, but yeah, I assume that everybody here at least has some awareness of what Helm is about. So yeah, how do we use it? So at Wunter, we have 3 charts. So we have the Drupal chart. Of course, we have a very strong Drupal history. This is really like it has all the features. It has Drupal, of course. It has MariaDB, Elasticsearch, Memcached, the different things that we use in combination with Drupal. It also has quite a few things in terms of like providing shell access, in terms of providing reference data for new environments. So for like we create a sanitized data that we extract to a dedicated volume, and then whenever we create a new environment, data from there. So there's a lot of things in there. And then we also have 2 other charts that we call simple. It's just a simple single container hosting, or actually it can auto scale, but by default it's just a single container, and we use it mainly for static sites. We actually have a few pretty high traffic Gatsby sites running this way, and it's always amazing to see how much traffic we can get with pretty much no resources. And then we have a third chart, which we actually use pretty heavily nowadays, which is made for Node.js applications that, or JavaScript applications, usually React-based with Next.js, that need server-side rendering, some kind of like API proxies or middlewares and these types of things. Turns out that, again, naming things is difficult because this front-end chart we actually use in quite a few places to manage back-end sites or middleware JavaScript code. But yeah, so that's the 3 charts that we have, and we have quite a few projects that we have using those. So pretty much every development that we've been doing for the past, like since last summer, everything that we deploy is entirely built on this, and also quite a few production sites nowadays. So and yeah, and maybe one point about how we structure things. So for us, everything is done through Git. That's the only way that developers interact with the system. And the way that we have things structured is that for each project, we have a namespace. So for each Git repository, we have a namespace. And then this is actually configured like automatically with our CI set up with a Circle CI. And then for each branch, there's a dedicated release, so a Helm release. And in there, we have all the various containers that are created by deployment, stateful sets, cron jobs, and so on. And yeah, that means that we have multiple releases that are created automatically and that are also deleted automatically whenever we delete a branch. So we also have 2 clusters. We have one for production, and there's only the production branch there. And we have a non-production cluster, which has pretty much everything that is not production. And it's actually bigger, and we have different resource allocation there. But we actually have quite a few releases at the same time. And for us, well, maybe before we talk about like what the changes are, for us, the main reason for wanting to move to Helm 3 is that we saw that there were a few issues that we were getting affected from Helm 2, and also in terms of timing, we have well, since we migrated, we onboarded a few larger clients, specifically like moving to production. And we want to make sure that this migration was done before that. So we didn't have that many environments at that point. It was a lot easier to make the migration before we created those. So changes, actually the main changes, you took them from the FAQ, the official FAQ. But I can quickly go through what it is that that is relevant for us. So the removal of tiller, actually, we never really had an issue with tiller, but yeah, it's definitely good not to have it. And we also noticed that tiller was sometimes a bottleneck, especially when you have a lot of releases in a cluster, like it's the case in our dev cluster. We saw that it sometimes needed a lot of resources, and not having it is actually a pretty nice thing. So it wasn't a big issue, but it's definitely nice to have. Another thing that we realized is, so with the way that Helm 2 actually does deployments, it takes a look at what it generated, so the templates that it generated for the previous values, and it looks at what the template that it generates for the current values and make a def of that. But that means that if you make any manual changes to your resources, Helm 2 generally will not revert those unless there is a change to the same part of the resource. And this is something that's actually not very intuitive, and most people actually, well, at least for us, we realize it like after having worked with Kubernetes and with Helm for many months already, and so when you realize this, is like, oh wow, that explains these sometimes weird inconsistent behaviors. And with Helm 3, there's a proper three-way strategic merge that is being done between the current version of the resource, what it was before, and then what was generated before by Helm, and the new version that's generated with the new. So this is actually something that is actually quite essential. And one of the tools that requires this is a tool that automatically downscales Helm releases, or actually any kind of Kubernetes resources. It's a bit based on the Osiris project. Works in a similar way, but it's able to, instead of just taking down one deployment, it's able to take down a deployment, a stateful step, stop the cron jobs and things like that. So we're able to scale down an entire release, Drupal release from that to nothing. And we had the issue that we were able to scale down, but then when you would deploy again, it wouldn't scale up. It's not exactly what you want. So we really needed this this migration to Helm 3 to be able to use this auto downscaling tool. Also, release names are now scoped to the namespace. And for us, that meant, and I'll show this, actually, I can just show this here. So since for us, we base everything on the Git structure, so if we have a relatively long repository name and then a relatively long branch name, we ended up with release names that actually were too long. And we had to shorten them because it was like very easy to hit those limits. And by shortening them, we added some hashes, which made things a bit cryptic. And then it was sometimes very difficult because like every feature branch is called feature, then project code name / and then the hash kicks in, and they're like, okay, well, like that could be any branch. And then with Helm 3, we have the repository name that matches with the namespace, and then we generate the feature branch, the release name entirely based on the branch name. And so it's we're pretty much able to generate things directly like that, and that gives us a lot more clarity in the way things are done. Also, something that we use quite a bit, validating chart values with JSON schema. So now it's possible to just drop in a JSON schema for the chart, for the chart values, and it automatically, whenever you create like upgrade or install or upgrade a new chart release, it automatically validates if the values are correct. And you can do a lot of things with JSON schema. So we're doing some basic testing that like we get the right data types and so on. And but we can also do some more advanced things. For example, if the release name is production or contains production, we guarantee, like we check that the various resources are not set to the default that we have for the non-development environment. So there's quite a few things that we can handle there. Also making sure that like, not sure. Well, that in production certain things are protected and so on. So there's a lot of things that we can do there. And this really, like, it saves the developers a good amount of time just like noticing typos before they deploy something and it doesn't work and they don't know why. But we also found that with Helm 3, it doesn't only validate with JSON schema for the values, but it also validates against Kubernetes APIs. And we actually found something like 5 or 6 different bugs in our resource definitions. Nothing major, but most of the time it was something that we thought did something. Job attribute, for example, and then we realized actually we have this in completely the wrong place, wrong indentation, something like that, and we actually caught quite a few things with that. So yeah, Helm 3 has definitely made our resource definitions much more solid. Yeah, library chart support. We're not really using it. That's something we might use in the future, but yeah, at this point, we don't really use it. Okay, so yeah, it's nice and shiny and all new, but how do we make the switch? So there's something that's supported out of the box. There's this Helm 2.3 plugin, and it pretty much like it leaves all the resources in place, and it just migrates the metadata about the release from one place to another. It's actually quite nice. It worked almost. One of the disadvantages is since it keeps everything in place, then it also kept the existing release names. And for us, we kind of wanted to get rid of that, but at the same time, there was no hurry to do that. So we would have been happy to keep those older, maybe sometimes cryptic release names. But the main issue was actually with the database charts. So it's something that actually affects both MariaDB and MySQL and any other database. And the problem is Helm actually adds, like a lot of charts actually, they generate to be assigned to all the resources. Release name is one of them. And then there's this label called heritage. And I'm not sure what it's there for, but with Helm 2, the heritage was tiller. And then with Helm 3 is Helm. And the is not so much like the labels that you add to the pods and to the deployments and so on, because there are ways to work around those. But the problem is with stateful sets that it's also applied to the persistent disks. Well, the persistent volume claims that are created by those stateful sets. And it's pretty much impossible to change a label of a persistent, an automatically generated persistent volume claim in a way that Kubernetes will not complain. It's a known issue. There's quite a few comments on the issue on GitHub, but there's really no workaround. At least not in a way that makes this Helm 2.3 plugin work. So if you have anything where you have databases, or at least these couple databases that we checked, they're managed with Helm, then the Helm 2.3 will probably not work. So that was the first option. Okay, that's not going to work, and we end up with a second option, which was to just create a new release. And because the release names have a different schema, we were just able to create a new release. And then what we did, we create a script to actually migrate the data from the old release to the new release. And in this case, it was actually reusing all the data. Also, the database credentials were the same between the old release and the new release. So we're actually able to migrate the data, the database content directly from one pod to another. Point we hadn't yet added the network policies, but yeah, at that point it was still quite easy to get the data from one place to another. And then when we actually created the new release, we had it initially with a dedicated, a different host name. This way, we had two ingresses side by side that were pointing to something different. And then once we were able to test that everything worked, then we just deleted the old release. And that actually worked quite easily. We did some testing in our development cluster. And then once we had a script that worked well, we just rolled that through everything. And yeah, we did it manually, one project at a time, just to make sure that if there were any issues, then that we could, that we didn't just go make too risky steps. But actually, I think we could have done that, and it would have been fine. But yeah, a lot of shell scripting for that. Thing though is that, yeah, I mean, things went relatively well, but there's definitely a few things that did not go exactly as planned. So one of the things that we realized is persistent volumes are not namespaced. Well, of course we knew that, but the problem is that if we have, for common branch names like master, it means that we have multiple projects called master. And previously, the persistent volumes were named based on the release name, and suddenly that doesn't work anymore because then you have multiple volumes that would be called the same thing. And in our initial test, we only tested on one specific project with a dedicated branch, and it's only when we started deploying this to additional projects that we ran into this. So yeah. Keep in mind, persistent volumes are not namespaced. The persistent volume claims are. But the persistent volume claims and the selectors on them are also not namespaced. So we need to, we actually ran into the same issue twice. That was also relatively easy to fix, but it would have been nice to think about that right away. Also, Helm 3 validates the release names. It didn't really do that before, but it's actually a nice thing. And it's the kind of thing, so when we switched to this new structure, we didn't need the shortening logic because we have a much longer name, 53 characters. And then we realized that we actually have developers who use very, very long branch names in some cases. Yeah, so that's not something that we're expecting, but yeah, it turns out that some people do that. Helm 3 validates that ahead of time, so it will refuse to create a release instead of just starting the deployment and then erroring out because there are some individual properties that are too long. Also, making changes across a distributed system, it takes a good amount of planning, and we didn't get it like completely right. Some coordination that needs to be done between the orb, which is the Circle CI package, the chart, and so on. So there's a few things that you need to keep in mind and really see, like, in what order, what are the intermediate steps. And also one thing to keep in mind is, like, how do the steps stretch out over time? Because it could be that somebody is just rerunning a deployment that happened a week ago, and then as like with Circle CI, if it reruns the deployment, it still uses the same version of the code and the same version of the deployment process that was defined at the time in order to guarantee consistent builds. But that also means that you need to be like to plan with somebody will use the new Docker file with the old deployment system and things like that. So nothing major, but a few surprises there that were actually easy to fix. And the last one that's also super easy one to fix, but Helm3 doesn't automatically create namespaces. So we have a system where the only thing that developer needs to do to create a new project is create the repository, enable Circle CI, and just push. And previously, that just worked automatically because Helm3 would create the namespaces, and now we had to update our Circle CI setup so that if the namespace doesn't exist, it gets created. Again, nothing major, but something that is good to know about. And for us, actually, we've been very happy with this. It was a messy migration, but when it was done, it was very, very nice to have this behind us, and we see that there's a lot of benefits to this. So our main takeaway, it's future-proof, and now we can focus on other things, which is very nice. So thank you, and any questions?
So one reason why I was not a big fan of Helm 2 until, so we never sort of adopted it to begin with. There are some workloads that sort of like ship with like Helm as the supported way to manage the application, and that's sort of, we'll follow the pattern, and Helm 3 is definitely nicer to do that because you don't have any tiller running. But for like, you guys are all in on this, like you do sort of branch review environments, and you've got all the, your whole infrastructure runs off of this. What's the selling point for doing this with Helm versus, for instance, like a custom resource definition and a controller that sort of provisions these things in the controller model? Because I'm still a little bit more well disposed to doing that for like our review environments than managing Helm charts.
We actually had to look at a few options, and pretty much all of the options end up with same kind of like negative aspects as Helm has. So like templating and YAML and things like that. It's not like in what we saw, it didn't actually make much of a difference, and especially now with Helm 3 that there's no tiller, it also in terms of security and permissions and so on, it actually works out quite nicely. We had a brief look at various solutions and realized, well, actually it just pretty much the same thing. And also Helm has a very nice ecosystem. Whenever we need something, like a couple weeks ago or months ago or now, somebody just needed a project, and we were just able to add it as a subchart, and then 5 minutes later we were done. It's nice to be able to make use of that ecosystem and still have something that's like very much tailored to our needs. And also there's, in terms of tooling, we use the Helm unit test plugin pretty heavily. So all the charts are unit tested, and we've seen that this is really really nice to be able to make changes to validate that we're catching the various use cases. So overall, I would say that we've been very happy with this.
Cool, thanks.
Any other questions? 50. Well, thank you very much, Florian, for the presentation. This was an awesome session.
Thank you.
So I know at the beginning I completely neglected to go through introductions. I apologize for that. I was a little excited. If anybody would like to introduce themselves now, you are more than welcome to. I'm Ellie, incidentally. I'm hosting the meeting today because Kevin is on an airplane. And I work at DDev. I'm marketing and communications and events when they're happening and all that good stuff. So anyone else want to do a little last minute intro? Uh-huh. All right. Well, you're all awesome, and I'm gonna let you go. So have a good evening, morning, whatever time zone you're in, and we'll see you next time.
Thanks for hosting.
Thank you.
Thanks, Ellie.